So now, how to take into account the irreversibilities that took place across the compressor and across the turbine when we consider a real Joule cycle, so when we want to take these irreversibilities into account. Without big surprise, the tool that we are using is the isentropic efficiency of the compressor and of the turbine. Without surprise, because it's what we have already done in the case of the compressors for vapor compression refrigeration cycles. Usually, for a given geometry or made of compressor of a turbine, we consider that in the whole range of usage of this device, we keep the same isentropic efficiency. We just need to be careful to one thing, is that the isentropic efficiency of a compressor and of a turbine is not defined the same way. So let's first consider the compression from A to B. The isentropic efficiency of the compressor is defined as the ratio between the technical work that would be required for the isentropic compression divided by the real technical work we have for the actual compression. Of course, it's written this way because the real technical work is higher, so we have an efficiency that is lower than 1. And the way it's defined, especially the point B, is, as we have seen before, it's from the same inlet, so from point A, which is usually known, with an isentropic transformation to the high pressure. So now, if we know the isentropic efficiency of the compressor, we can use this value to calculate as well the properties of point B, but also the technical work exchange on the real transformation by expressing it as before for the ideal Joule cycle for an isentropic compression, and using this new factor, which is the isentropic efficiency. And in that case, we can express the technical work of compression as the same expression we had before, but divided by the isentropic efficiency of this compressor. For the expansion across the turbine, we do exactly the same thing, but be careful, the isentropic efficiency of the turbine is defined another way. It's defined the other way because the real technical work we can get from this expansion is lower in the real case than it was for the isentropic case. So in that case, we divide the real technical work from C to D by the isentropic work from C to D is. And then we can do exactly the same thing. So in that case, we need to multiply the isentropic technical work that is exchanged by the isentropic efficiency of the turbine. And so that's how it's usually done to calculate this real transformation when we take into account the irreversibilities in the compressor and in the turbine.